Hi everyone, today we're going to be talking about an animal that is very near and dear to my heart. If you haven't guessed it yet just by looking at our dress, today we're going to be talking about starfish, or more accurately, sea stars. Let's go ahead and get started. Sea stars are not in any way, shape, or form related to fish, so calling them a starfish is not scientifically accurate. But what you really call them doesn't matter because it doesn't change how cool they are. So if you say starfish, I'll probably say it throughout this video. I'm not offended, you're still fine. So sea stars, not being fish, are not even vertebrates. So fish are vertebrates and have a backbone. Sea stars are invertebrates and don't have a backbone. And sea stars are part of a phylum called echinodermata. So if anybody remembers from like elementary or middle school, the mnemonic device King Philip came over for Great Spaghetti that allowed you to remember the different taxonomic classes: kingdom, phylum, class, order, family, genus, species. I think I got that right. And yes, that does just kind of live in my brain rent-free, so there's that. If anybody remembers that, those are different orders of taxonomic classification. So the more specific you get, genus and species being the most specific, the closer related something is. So while both fish or other mammals or other vertebrates, while fish, mammals, or other vertebrates are all in the animal kingdom, sea stars are also in the animal kingdom. If you go one step more specific into phylum, all of fish, mammals, things, us, we're in the vertebrates, and we're in phylum Chordata, and the sea stars are in phylum Echinodermata. And Echinodermata also includes stuff like sea urchins, sand dollars, brittle stars, sea cucumbers. All of those are in Echinodermata, and they're all unified by sharing a couple of characteristics, such as having radial symmetry as an adult, having calcified skeletons, and having a hydrostatic skeletal system. And I will talk more about each of those all in turn. But all echinoderms, and since this video is about starfish or sea stars, I will be specifically talking about them, have a pretty wild reproductive and life cycle. So for a sea star, sea stars can reproduce either one of two ways. So either the male and female sea stars are just chilling and living their lives, and then when they want to reproduce, they just basically spew forth eggs and sperm all into the water column or into the ocean. And then those eggs and sperm meet, get fertilized, and turn into baby sea stars. Or some types of sea stars actually will brood or kind of like carry around their little babies at a much lower number on their bodies themselves. The sea stars that opt for the let me spew my eggs and sperm out into the water and see what happens strategy can release like millions and millions and millions of eggs during one reproductive kind of cycle. And the reason they do this, is sending millions of eggs out into the water, is because they just send them out and whatever happens, happens. So the likelihood of them getting fertilized is low. The likelihood of those fertilized making it into viable baby sea stars is even lower. And the likelihood of those sea stars making it from baby sea star to adult sea star is even lower than that. So you may have millions of eggs in the water column being released per reproductive period, but maybe only like 1 to 10 adult sea stars come from that. So it is a certain life history strategy that some animals use, is just make a lot of babies because not a lot of them are going to survive to adulthood. So once you have a fertilized egg, that sea star is now a larval sea star. It's a little baby, and they look nothing like gigantic sea stars, or adult sea stars. I'm gonna show some pictures. They turn into what are called bipennaria larvae, and then they grow bigger, or they start out as a gastrula larvae, then they turn into bipennaria, and then they turn into brachiolaria, which are all really, really fun names, but look nothing like the adult sea star. And then they start to develop what kind of looks like a spiky butt. And that spiky butt is called a rudiment. And that rudiment is actually going to grow and grow and grow and grow until it encases the larval sea star. And bam, now you have a juvenile sea star, which is what is on my dress, these little juvenile sea stars. And juvenile sea stars look like baby versions of adult sea stars. And now they start to show that radial symmetry, or the symmetry that comes forth in multiple points starting from the center, that is seen by all echinoderms. So now you have to, when juvenile sea stars will settle onto the ocean floor and eat and slowly grow into larger and larger adults. But there is a very big life change from baby sea star or larval sea star to adult sea star. A lot of animals don't undergo this kind of drastic life change. Think about humans, for example. Babies look pretty much like tiny humans for the most part. They don't look like random aliens, and then all of a sudden, bam, when they hit the teenager stage, start to look like little mini humans, even though sometimes they may act like aliens at the teenager stage. But baby sea stars look vastly different from adult sea stars, and that's just a really cool thing about sea stars. And actually all echinoderms will undergo a similar drastic life change. So let's talk a little bit about the adult anatomy of a sea star now that we've talked about their little babies. And so adult sea stars have radial symmetry. They have, like, you can cut them in half along multiple lines and they'd still be symmetrical. And they also all have what are called calcified skeletons. So they have these little like pieces of calcium bones that are in their body that are called ossicles. And unlike our human skeletons that are all in one piece more or less in like inside of our body, the ossicles are kind of embedded into the starfish and are kind of like outside the starfish and inside the starfish, almost kind of like a moving living skeleton going along with it. And this actually dramatically impacts the texture of a starfish. So I'm gonna name a bunch of species all from the Pacific Northwest. So you have like Piesaster or ochre sea stars are really rough and spiny because they have a lot of ossicles on the surface of their skin. And I actually collected them for research, and like I've lost many a battle to trying to pry an ochre sea star off of a rock because they stick on really tight and they're really hard and spiny, so they'll like cut your hands open while you're trying to grab them. To a leather star, which is very, very smooth, feels very leathery, to Henricia, which is a little bit in like an in-between texture, to even a Pycnopodia or a sunflower star, which are really, really, really squishy and look like aliens and have like 20 arms. These are all because they have either big ossicles or really tiny ossicles that are located closer to the surface of their skin, or they're located inside of their skin. The different types of ossicles and stuff like that make very different looking or feeling sea stars, but they all do have ossicles. Finally, sea stars are all united by having a hydrostatic skeleton. So instead of us who use, like, again, we have muscles that push and pull against joints or bones in our body to move, starfish and other echinoderms will use what is called a hydrostatic skeleton. And actually a lot of other animals will use this as well. So they just have tubes throughout their body that are filled with water. And by contracting or expanding different muscles, they can move the tubes of water. I realized I'm moving this way and you guys don't understand why I'm moving this way. So imagine that I was just filled with a bunch of water. And if I wanted to move to my left, so camera right, I believe, I would contract the muscles on this side of my body while expanding these muscles and push that water over to the one side. And I could do the reverse to come over here. So that's how all echinoderms get around. And if you look at the underside of a starfish, they're covered with thousands of what are called tube feet. And they're all these tiny little tubes of water with basically like suction cups at the end of them that can stick to walls or rocks and are moved by pushing and pulling their muscles to move the water through them. Pretty cool. So yeah, starfish, adult starfish are gonna practically live they're gonna live in tide pools or on the ground. They're gonna be attached to rocks. And sometimes they can get really attached to rocks. Baby starfish, on the other hand, don't live attached to rocks. They actually float around in the water and swim around in the water and eat stuff, and they basically make up the plankton in the ocean. And then when they turn into juveniles and adults, they settle down to the ocean floor. You can find starfish pretty much anywhere in the world. They cover a lot of different regions, different species in a lot of different places. I'm most familiar with the ones in the Pacific Northwest in the United States because that's what I used to study in my research in college. They eat a lot of like bivalves, so mussels, clams, scallops, and they can use their muscles and those tube feet to actually pry apart the shells of those animals to get to the meat inside of them. And they'll actually like kind of puke up their mouths almost, like out their mouths, and take stuff in and then re-swallow it. And a lot of starfish don't actually have, or I don't know if any of you have, like a separate butt, so they actually eat and poop out of the same hole. It serves multiple purposes. Starfish don't have eyes the same way that we think of having an eye and able to see, but they do have eye spots on the end of their arms that allow them to kind of sense dark versus light in order to get a little bit of visual information from what's going on around them. They also don't have a central nervous system. So like we do, we have a centralized nervous system in our brain. Starfish don't have that, so they don't quite feel pain the way humans do. And that's part of the reason they are able to regenerate. So if a starfish loses an arm, it can regrow that arm. And if they lose an arm in the correct, like if they lose an arm and it has a little part of the center of the starfish on that arm can actually regrow a whole nother starfish as well. And then I've mentioned this before, but their larvae can do the same thing, where their larvae can split in half and regrow each other and clone themselves. So starfish are pretty rad and pretty cool and have a lot of amazing capabilities. I hope you enjoyed today's video and learning a little bit more about sea stars, which are my favorite invertebrates. I think they're super cool, especially for an animal without a backbone or without eyes or a central nervous system. They do a lot of really cool things and have a really cool life cycle. And a fun fact we're going to rate is that in addition to not having any of the other things I just said starfish don't have, sea stars also don't have blood. So if you cut open a sea star arm, which I have done before, it's not going to bleed. You'll just see a bunch of stomach and 2 feet. Super fun. So please be sure to rate that comment and rate that fun fact in the comments below. Like this video, please subscribe to my channel. I post every Tuesday and Friday, and I love making videos for you guys and sharing all this information with you. And keep it sciencey.